Alright, you're welcome once again to another video. Welcome back to the YouTube channel. I remain Pendulum and I'm your tutor on this channel. And as always, we are here to learn mathematics. And this will be our final video on quadratic equations. Today we'll be looking at the nature of quadratic equations. We've looked at a lot when it comes to quadratic equations. We've looked at how to solve it by factorization, by completing the square method, by using the quadratic formula. We've looked at the roots of quadratic equations, sum of roots, product of roots, and all of that. So today we'll conclude by looking at the nature of quadratic equations. Nature of quadratic roots. Okay, so if you're new to the channel, I will urge you to subscribe to this channel because you will learn a lot here when it comes to mathematics. I try as much as possible to keep these lessons as detailed and as simple as possible. So subscribe please if you are new here, and as you watch, do well to like the video, drop your comments if you have questions or whatever, and then share the video with someone you know. Share it to your friends, share it to fellow students, share it on your WhatsApp status. Alright, so you're welcome again. Now we have something on the board, so I will go through it one by one and explain what it is. This is actually very simple. Okay, so now if you have watched the previous videos, there was a time, I think, when we looked at factorization, when I told you that a quadratic equation can have three types of roots. Alright, they can be real and distinct, real and equal, or imaginary. Now I told you that after we had finished solving the equation and gotten our answers, we've gotten the two roots, and then we are able to now know, okay, this is the type of root it had. It has two different roots or two different solutions, or it has only one solution. But what if there's a way to know the type of roots or the type of solution the equation has without even solving it? And that's what we'll be looking at today. So if you're given a quadratic equation, you'll be asked to find out the type of roots or the type of solution it has, and you can do that without even bothering to solve the equation. Okay, and to do that, to determine the nature of the roots or solution of a quadratic equation, we make use of the discriminant. That's capital D in brackets. So if you ask to find the nature or the roots or solution of a quadratic equation, if you ask to find the type of roots or the type of solution a quadratic equation has, you are going to use the discriminant. Okay, this is how you are able to solve it without having to this is how you're able to get the roots of the equation without having to solve the equation completely and getting the answers before you can determine the roots. Okay, now the discriminant D is equals to b squared minus 4ac. All right, if you remember your quadratic roots, you remember that if you remember your quadratic formula, you remember that this is taken from part of the quadratic formula. This b squared minus 4ac is the term under the brackets, under the square root in the quadratic formula. Okay, so if it looks familiar to you because you've seen it before, it's from the quadratic formula. We call this part b squared minus 4ac the discriminant, and you can use this to determine the nature or the type of roots or solution a quadratic equation has. Now there are three cases, like I said, and you need to note the following. If you solve this b squared minus 4ac, if you solve it and your d is greater than 0, if you solve it and you have an answer that is greater than 0, it means that that equation has roots which are real and distinct. This is the first type of roots I told you. That means it has roots. If d is greater than 0, remember this condition, then the roots are real and distinct. That means you're going to get two different roots or two different solutions. One may be positive, one may be negative, both of them may be negative, both of them may be positive. You may have fractions or what have you, but you're going to get two real numbers, two different numbers as the root if your discriminant is greater than 0. Okay, that's the first condition. The roots are real and distinct. Now if you solve this, b squared minus 4ac, you put in the values. Remember, I've told you time and time again what is b, what is a, what is c when it comes to quadratic equation. B is the coefficient of x. The term or the variable is raised to power 1. This is the coefficient. This is the number beside it. A is the coefficient of x squared. The unknown or the variable raised to power 2. The term beside it, that's the coefficient, is a. While c is your constant, the number that stands alone. Okay? So that's just a reminder. Now if you solve and d is equals to 0, if you solve this and you get 0, that means d is equals to 0. It means the roots of that equation are real and equal. The roots are real and equal. What does this mean? You're going to have only one solution repeated. Okay? If you solve and d is equals to 0, the roots are real and equal, meaning you have only one solution for that equation repeated. So you're going to get maybe x is equals to 2 or x is equals to 2. X is equals to minus 3 over 4 or x is equals to minus 3 over 4. You're going to get two answers that are the same. That's real and equal or repeated. You can also say it has only one solution. Okay? We'll take examples so that you see all this. And then finally, if you solve this, your discriminant b squared minus 4ac, and the roots and the answer you get is less than 0, that means if you get a negative answer, it means the roots of that equation are imaginary. The roots are what? Imaginary. What does that mean? The equation has no real solution or roots. Okay, that means the equation is not that it's not solvable, but it's going to give you complex numbers. Complex numbers are a different branch of mathematics. They are not real numbers. Okay, that's when you have the square root of a negative number. All right, so if you solve this and you're getting an answer that is negative, that is less than 0, it means the roots are imaginary or the roots are complex. It has no real solution or roots. So you have complex solutions or it has no solution. That's what you say. Okay, now let's see these examples. I have about 7 examples here. We are asked to prove the nature of roots for these equations. Now what I'm going to do, I'll do the first 4 and then I'll leave you to do these 3 as assignment. Okay, you know I always give assignment on this channel because I believe that it is by actually trying your hands at this that you can be sure that you've understood it. That's the only way you can test your understanding of what you've learned. So I'll leave these 3 as assignments and then I'll do the first 4. Same process. Very simple. Now let us look at what to do. Now we have x squared plus 2x plus 2. Okay, and from here we know that our a, okay, first we have our discriminant is b squared minus 4ac. That's our formula. Okay, from this equation you can tell that a, the coefficient of x squared here, is 1. B, the coefficient of x here is 2, and c, the constant, is also 2. If I put into that formula, I'm going to get that d is equal to b is 2 squared. I'm using this formula, that's this 2 squared minus 4 times our a is 1, our c is 2. If I multiply this out, 2 squared is 4 minus 4 times 1 is 4, 4 times 2 is 8. Okay, So I have 4 minus 8, which will give me minus 4. That's my answer. Okay. Now, when you get this, what does it tell you? Like I said, if d is less than 0 or if d is negative, the roots are imaginary or it has no real solution. Okay. So what this simply tells us is that this first equation, because d is negative, d is less than 0, this has no real solution. So I can say the nature of roots imaginary, and you can prove it. I won't do that, but you can prove it. I've shown you how to prove it. That you can solve this, or you can try to solve it, maybe by factorization, by completing the square, by quadratic formula, and see if you'll be able to get real numbers as your answer. You will find out that along the line you'll be having the square root of a negative number, which will now involve you going into complex numbers. So that's why I say it has no real solution. The solutions are imaginary or complex. So I hope this is clear enough. This is actually very simple. Number 2, 2x squared minus 12x minus 7. Okay, that's the second one we have to solve. We are still using this formula. It's a very simple formula. Now from here, our a is 2. That's this, the coefficient of x squared. Our b is minus 12. Our c is minus 7. Alright, so let's put into this formula. We have that d will be equals to b squared minus 12 squared minus 4 times 2. That's a, c minus 7. D is equal to minus 12 squared, that's minus 12 times minus 12 will give you 144, positive 144. Then here you have minus 4 times 2, that's minus 8. 4 times 2 is 8, minus 8. Then minus 8 times minus 7, minus minus is plus. I think 8 times 7 should be 56. Okay. Now if you add these two, you get 144 plus 56. I think this should be 200, right? Yes, I think this should be 200. If I'm not wrong, this should be 200. Now, clearly, 200 is greater than 0. Okay? The simple thing is, if you have a positive answer, the roots are real and distinct, because anything greater than 0 is positive. If you have 0 on the dot, then they are real and equal. And if you have a negative answer, the roots are imaginary. So in this case, our answer here, real, let me just write the abbreviation, and distinct. You can also prove this if you solve this by whatever method you want to use, factorization, completing the square, quadratic formula. You'll find out that you will get two distinct answers, two different solutions as the answer to that question. Let's look at number 3. We have x squared plus 2x plus 1. Again, our a is 1, that's this. B is this one, coefficient of x. Our c is the constant, 1. Now, we still have our formula b squared minus 4ac. So d is equals to b squared is 2 squared minus 4ac. Okay. Now 2 squared is 4 minus 4 times 1 is 4. 4 times 1 is 4. So 4 minus 4. And this is what? 0. Now, since our answer is 0 on the dot, it proves or it tells us that this third equation will give us two answers that will give you roots that are real and equal. Okay, so we are going to have repeated roots. If you solve this, I think if I'm not wrong, you should be getting -1 or -1, or 1 and 1. I can't tell if it's positive or negative 1, but I know you'll be getting 1 and 1 or minus 1 and minus 1. You can solve it and know which one it is actually, but you're going to get two solutions that are the same. You're going to get two repeated answers because, as you can see, d is equals to 0. So you can prove that one by yourself. So the answers here are real and equal. Real and equal. And then finally, let's look at the last one. We have that 3x squared plus 3x plus 3. Okay. Our a is 3, our b is 3, our c is 3. If we use our equation that d is equals to b squared minus 4ac, we're going to have that d is 3 squared minus 4 times 3 times 3. b is 3, a is 3, c is 3. Now this will give us 3 squared is 9 minus 4 times 3 12, 12 times 3 36. So this should be minus 27. Okay. Now again, that answer is negative. So it tells us that this solution is imaginary. Meaning if you solve this equation, if you solve this third equation, you're going to get complex roots. Okay, it has no real roots. You'll be having complex numbers. You'll be having a square root of a negative number. All right. So as you can see, this is really quite simple. Okay, and there's nothing much here. This video will be short because this is quite simple. So try these three as assignments. Try these three as assignments and tell me what type of roots this is, and this is. Remember, I said this is to help you if you're asked to determine the nature of roots. You don't need to solve the full equation before you're able to know what type of root it has. Okay, this is like a shortcut. Just like the last video, if you have to find the sum of roots or product of quadratic roots, you don't have to solve the whole equation before you get the answer. All right. So this is where we draw the curtain on quadratic equations, except maybe I come across some other thing or some other part of quadratic equation that I feel will be helpful to you. But I think with this we've covered enough ground when it comes to quadratic equations. All right. So in the next video we should be going into a new topic, and the next video will be dropping soon. So please ensure you subscribe to the channel so you don't miss it. Ring the notification bell. Just tap that notification bell beside the subscribe button so that you will be notified whenever a new video goes up, and you'll be among the first to watch it and to learn. Don't forget to like this video if you found it helpful, which I'm hoping you did. Drop your comments. Let me know if you are enjoying the videos on this channel. Let me know if there's anything you want me to change or anything you want me to continue with. All right. Share the video as well to your friends. If you have fellow students, share to them. Put it on your WhatsApp status. Share it to your children if you have. Okay. Thank you so much. You can join our Telegram community. The link is on the description of this channel, or you can reach me on WhatsApp if you want to reach me and maybe talk with me personally. My WhatsApp link is also in the description of this channel. Thank you so much. I am Pendulum, and my mission is to make mathematics as simple as possible for you. I always tell you, keep learning. The more you learn mathematics, the more you find out that there is nothing to be afraid of when it comes to mathematics. I'll see you soon. Till then, take care. Bye.